Hi, for this tips and tricks video, I'd like to share with you three things: how to create polylines, how to use the chart viewer, and also exporting CSV data within CFD Post, things that I find very useful and use quite often. So for this example, I've pulled up a Vane pump. We've got the inlet shown here on the right in blue now, the outflow in kind of a brownish burgundy color. The flow's coming in. The Vane pump is actually rotating counterclockwise, throwing the water out and then up through the top. Before we create the polyline, what I'd like to do is show you quickly how to, we're going to go to creating a surface group. We're going to call the surface group rotor walls. Surface group rotor walls. Okay, hit OK. And then what we're going to do is select several locations, all of them being really the parts of the rotor itself. I had left mouse click, shift left mouse click to select all the parts, all the faces. Select OK. Color, we'll go with gray, that's fine, hit apply. Now you can see our rotor much more clearly. We also have a plane that you've seen cut through. Actually, I've got a contour here that's working on plane 1. This plane 1 is going to cut through the middle of the rotor. And one thing nice about creating this surface group is rather than toggle on all of these individual components, I can group them together and toggle them on or off as a group. I can also, if I double click and select that, color is gray is fine. We can also make that gray a little lighter if we like, and hit OK. And then also one thing that's very helpful is you can make it transparent. So make it 0.7 for transparency. So now we still see the surface that's defined by the rotor, but we can also see that contour plot that we've created here. This is a pressure contour through that midplane. Okay, so now to actually create our polyline, we also go up to a location. That's where all your points, your lines, your planes, ISO surfaces. There's also polyline is one of the selections. We select that. Polyline 1 is fine. We hit OK. There's several ways to define it. What I like to do is define it as a boundary intersection. I want to intersect the outer wall of the rotor. Now it kind of highlights here. You can see it with the mesh. And I want to intersect it with. I usually select the 3 dots. I select the 3 dots. It gives you the whole list. It's easy to select the item that you want to use. So we're going to select that intersect that with plane 1. We select OK. And then for color for this line, we can go ahead and leave it this green, but let's make it a thicker green so we can really see where that line is located. We hit apply, and there it is. You see it rotating around the entire rotor surface. And if we maybe don't like the green color, we can always make that a black. If you think that's a little easier to see how that looks. Yeah, that looks good. So now that we have our polyline defined, what we're really interested in is finding the wall shear stress distribution around the rotor surface, particularly where the vanes come in and out, where they're in close proximity to the rotor itself, where you expect much higher wall shear. So to do that, we come up to here where we see our little indicator is this chart viewer. And chart 1 is fine. We hit OK. The title, we can title it if we like. We call it wall shear distribution. Our data series. This is where we select the location that we want to plot. So for our selection, we want polyline 1. Now we go on to the next tab, which is the x-axis definition. And here we can leave it default as chart count. But what I think would be really most helpful, again, click on the 3 dots, give you the whole array of options to select. I really want to see theta, which is the distance kind of around the perimeter. So we have theta there. This is our x-axis. For the y-axis, again, pressure comes in as a default. I'm interested in wall shear stress. It's right there. We select that, and we do our line display, and then we hit apply. So this is our wall shear stress distribution in pascals versus theta around the rotor surface. And we can see the 2 locations where the vanes are quite close to the rotor surface. We have the increased wall shear. And then if we actually want to look at, this is of course a line plot. If you'd like to look at the line display, there's several options there. What we can also do is symbols automatic. We can have them be actually ellipses. Hit apply. And so this actually shows us the actual locations of the the data, the mesh where that wall shear stress is being taken. So sometimes it's really quite helpful to see, if you actually captured the peaks that you're interested in, or if you need to include additional mesh refinement in certain regions. One thing that was really nice with this model, which was set up, is you noticed that it had variables such as theta, and that was enabled really through this turbo tab, which is for models like this. It's really helpful. So you can actually, if you want to, you can define a rotational axis. Here we just use the rotational axis from the definition file, so that's fine. You can also initialize all the components. We've already done it for this model, but it goes and calculates all the turbomachinery related quantities, which we'll look at in just a moment. And then also you can calculate your velocity components by just clicking this button, which gives you your velocity components in the r theta z direction. So if you go back to our outline view now and we pull up our contour, and for our variable, we click on the three dots. At the very bottom, scroll down to the bottom. These are all the turbo quantities that are calculated. So they're really quite helpful, particularly our radius, theta, the velocity components in the three circumferential directions, the r theta z, and so it's really a nice tool for turbomachinery models such as this. Close out of this. So the last thing I'd like to show you is how to export this polyline data. So we go to File, Export, Export, and I'm going to expand this over a little bit. So you have the first option is your file name, and we'll just say this is Vane pump wall shear. Say OK, save, and then type's generic. The name alias, actually the location is the next thing we need to pick, which is our Polyline 1. Again, hit the three dots, Polyline 1. We're telling it where we want to write out this data, the source of the data. We can name it. So we can say this is rotor wall shear stress. And then at the bottom, it automatically, by default, it exports to the geometry information, so your X, Y, Z information. Let's say we also want to include other variables. Maybe we might want to have, let's scroll down here, let's write out density, let's write out the main things we're looking at. Let's scroll down further. Let's look at pressure. And what I'm doing is I'm holding down the left control button. That allows me to make multiple selections. And the other thing the other thing here, right? I'd like to get theta, and I want my wall shear stress. Let's scroll to the bottom for that. My wall shear, and then I say save. So what it says, what does, it writes out a .csv file. So to find that file, this model is entitled CFX Vane Pump Demo Files. That's the Workbench project file. So I go in there, and all the, of course, all your images you create, but also these Polyline, our exported data is in the user files directory. This is our file right here that we named Vane Pump Wall Shear. We double click, open that up, opens up Excel. And then what I often do is I'll come in here and I'll center the data, and I'll also let's make this a little wider so we can see what we have here. So it has the data that we really that we specified. We've got your X, Y, Z data. We've got our density, our pressure, our theta, and wall shear. So from this, again, we can name this however we'd like to further document this particular model. And then you can easily come in and pick your theta. And we're going to come up here, we're going to insert line plot, and there we go. We've got the same data we created in Safety Post, but now we have it in Excel if we want to take it and further modify it however we'd like. So it's a really handy way to, again, get more quantitative data from your solution, write it out to Excel, and then it's easy to share with others who want to look or further post-process this data. Thanks for your time, and I hope you found this video helpful.